In this question, we are asked to find the Maclaurin series for 2 plus x squared to the negative 1. So the Maclaurin series is simply the Taylor series centered at a equals 0, which is our most familiar type of Taylor series, what we've been doing most of the time. So I'm going to rewrite this as 1 over 2 plus x squared. And then we're going to say, does this match one of our favorite functions, which I know the Taylor series for, or the Maclaurin series for, and adjust it in a similar fashion. So we do know that 1 over 1 minus x is sum of x to the n from 0 to infinity. So I'm going to write this in a similar fashion. I'm going to use this fact. So let me save that over there. 1 over 1 minus x is sum from 0 to infinity of x to the n. So I need to make our function look like that function. I need it to be 1 over 1 minus something. So this I can rewrite as 1 over 2 times 1 plus x squared over 2. Essentially, I factored the 2 out of both of these pieces. Since there's no 2 there, I need to put it in the denominator, which is now 1/2 times 1 over 1. So far, so good. 1 and 1. That plus I'm going to turn into a minus simply by just putting the minus sign with the x squared. And now it's 1 over 1 minus something. So this piece goes in place of the x. And by doing so, the 1/2 is 1/2. 1 over 1 minus x is x to the n, but now x is negative x squared over 2. So that's sum from 0 to infinity of negative x squared over 2 to the n, which then I can simplify by distributing my exponent. So that's 1/2 sum 0 to infinity. I need to distribute that exponent to all pieces, so that's minus 1 to the n. That will be x to the 2n, and that will be 2 to the n. And then I have to do one more piece. Since I have a 1/2 out front, I can actually distribute that inside as well. By doing so, I get an extra 2 in the denominator on all pieces. So that's minus 1 to the n, x to the 2n, and the denominator will be 2 to the n plus 1. Because there's an extra 2 that gets attached at each place from 0 to infinity.